Hey everyone, I'm Alex Noonan. I'm a developer advocate here at Dagster Labs, and today I have an exciting project that I want to share with you. We are going to build a RAG project end to end from scratch using Dagster. A RAG stands for Retrieval-Augmented Generation, and it's a method of doing AI development where you have external context that you provide to a AI service that can then use that context to answer questions that are outside of its training window. This is really useful if you're doing like specific use cases, if you have like frequently asked questions for a customer support bot. At Dagster, we use a RAG for our Ask AI tool, which in our Slack and website, you can ask it questions about Dagster, errors with your code, and you can get a relevant answer with some sources attached to it. AI pipelines are data pipelines, and the Dagster abstractions work really well in these use cases. And for this tutorial, you'll be able to complete it within the free tier of Pinecone, and I was able to only spend about 12 cents of OpenAI credits. So in this tutorial, we'll build a Ask AI chat support bot from scratch using Dagster. The architecture is pretty straightforward. We'll scrape the documentation site along with the issues and discussions on our main GitHub repo. We will embed all that text in a Pinecone database. We will retrieve that text using OpenAI to get our answers. The completed project is in the description, but let's build it step by step right now. Let's get into it. So let's go about actually setting up our project here. First, we want to create a folder for our Dagster project. Then I'm taking a look at this pyproject.toml file. We're going to create our virtual environment, activate it, install all the dependencies. And the toml file is like the configuration file for the package. It tells us where the project is, the description, the version, and the dependencies. We're also going to need some environment variables. The instructions on how to get all these are in the README for this project. And then next, we're going to create our resources, starting with the GitHub one. And for this, I'm going to copy the resource we have from Dagster Open Platform, because there's no sense in reinventing the wheel when we just need to change a tire. Additionally, in Dagster Open Platform, we have some GraphQL queries for GitHub. So I'm going to post those in here. And we're going to need to add a few functions onto this class to work for this use case. So what we have here is it's returning a list of results. We want to convert those to documents, which are a data type that is used with LangChain and helps convert the data so it can be processed inside the Vector database. And then at the bottom here, we're going to initialize our resource using that environment variable we created earlier. And the next resource we're going to make is our web scraping resource. So to do this, we're going to utilize Beautiful Soup and requests. And we are going to scrape all the pages on the Dagster docs site. And one thing with web scraping is sites generally don't want you to do it. Before you do this, you should always check the robots.txt file. If you look up here, we have a headers object that we're going to set our user agent with. So it'll give our scraper the appearance that it's a user from the browser. There's other things you can do, but that's for another time. And then here we are parsing the sitemap. So we're getting the sitemap as XML. We're going to soup it. And then we're going to parse all the URLs out of it and return that list of them. Next, we're going to create a function for scraping the individual pages, and this is going to return a document that we will then embed in Pinecone. So whenever you're doing scraping, sites are inconsistent with how they're structured, so you're going to want to have exception handling in here. which we have in our try and accept statement. And same sort of pattern here. We are requesting the URL, returning the text as a beautiful soup object, which parses that. And then we're going through the page and we're getting the title as well as the actual content on the page, which we will use to embed that. And for the exception here, I'm just going to log an information statement in our Dagster logger, and we're just going to tell which page failed and why. And then finally, we're going to initialize our scraper resource so it loads when the resources are all loaded. And finally, we're going to create our Pinecone resource. And a Pinecone is a vector database, and a vector database is a tool that's optimized for doing this embedded search with AI tools. Namespaces roughly correspond to tables if you're familiar with relational databases. So the first thing we're going to do is create a setup for execution function that initializes the class. And then next thing we're going to do is create a index. Index roughly corresponds to the schema inside your vector database. And the dimensions correspond to how big your objects are within your index. So we're just creating an index if it doesn't exist, and then we're using cosine similarity for these. And we're also specifying where this Pinecone database is. And now we're going to make a function to retrieve the index and namespace, which we'll use to upsert our data into Pinecone. And like the other resources, we're going to instantiate this here at the bottom using our environment variables for the Pinecone API key and the OpenAI key. Now that we have our resources configured, a step I like to do at this stage in the project is to create our definitions object and then load the resources in and start the Dagster web server to make sure everything works properly. So now that the Dagster UI is started, we can see that we now have our resources. Now the next step is to create our ingestion assets. And we'll use the resources, and since we did a lot of the legwork in developing our resources, the assets will be fairly simple. For the GitHub issues and discussions, we're going to want to create a weekly of partitions for these data assets. GitHub rate limits you, so by partitioning bi-weekly, we can get around that. So for this, we are also going to add a automation condition to run this weekly on a cron job. Now this function will use our GitHub resource to fetch the issues and convert them to a list of documents that we will then embed in the following asset. Now the next asset will be for the embeddings of the GitHub issues. And for that, the kinds we're going to use Pinecone, GitHub, and OpenAI, since those are the resources associated with this asset. And something special about the Dagster OpenAI integration is that when you make OpenAI calls within your asset, the Dagster integration will tell you how many tokens you use. So it'll create a audibility trail where you can understand what your consumption level is for your Dagster assets. And here we are creating the index and namespace if it doesn't exist. And we are getting the list of documents from the previous asset. When you define it inside the function parentheses, like we have here, you are telling Dagster that you're using the default IO manager. And here we are calling OpenAI and we are embedding our text. And then now that we have our text embedded, we are going to attach some metadata and then upsert it into the Pinecone database. Now that we have these assets, I'm going to add them to our definitions object and see how they load into the UI. So let's materialize the latest partition of GitHub issues raw to make sure everything works properly. We have the default automation condition turned on, so that should trigger a run for the embeddings asset, which it did. Now the output of the GitHub discussions is a little too complex for the default IO manager. So we're going to create a custom one for our documents that we'll then use for our other ingestion assets. And essentially all this IO manager will be doing is having a default structure for serializing and deserializing the output from the assets. And IO managers are considered a resource, so we're going to add that to our definitions object, and then we're going to add it to our assets. So our GitHub discussions assets are going to look pretty similar to our issues ones. The main difference is the GitHub discussions includes more text. And when we do the embeddings, we'll need to chunk up the text so we don't get hit by the OpenAI rate limit. Now for our last piece of the ingestion, we're going to create our web scraping assets. But before we do that, the text on the docs site can be a little long for doing the embedding and upserting into Pinecone. So we're going to chunk up that text a little bit using this function so they can be of equal size before we load them in. So for the web scraping raw asset, we're going to use that web scraping resource we created earlier, and we're also going to use that document IO manager to process the documents from that. And the first thing we're going to do is parse the sitemap, and then we're going to iterate through all the URLs and scrape the text from those pages and add them to a list. And for the embedding asset, we are going to take in the documents from the previous asset, and we're just going to use an eager condition for this because there's no partitions. So what we're going to do is for each of the pages, we are going to chunk them up into bite-sized pieces that OpenAI can embed, and then we are going to hash the URL as an index for each specific page, and then we are going to upsert them into the Pinecone database. And now that we have these assets in place, I'm going to navigate to the UI and materialize these to make sure everything works properly. Now that we've materialized the doc asset, we can see the amount of OpenAI tokens that were used. As you can see, it looks like a lot, but when you navigate to the OpenAI dashboard, you can see we only used 11 cents so far. Now for the final asset, we want to create an asset that essentially encapsulates the prompt that we use to interact with our vector database. And this asset will take in a structured input that will be this question config here. So the first thing this asset's going to do is embed the question and then use the vector database to search for a relevant answer in both the GitHub and Docs namespaces. Finally, we're going to insert any search results that it found into a system prompt, and then we're going to interface with the ChatGPT completions API to answer the question. And then the user will return the answer formatted as we define in this function, as well as the top 3 sources associated with it. And then now that we're in here, let's add that asset to our definitions object, and we'll be ready to test it out. In the meantime, I backfilled all our GitHub assets. So now our vector database has all the relevant text, and we're ready to prompt it. So let's prompt this bad boy and see what we can get. And the first thing I'm going to ask is kind of a generic one, like asking what is Dagster. So let's see what our RAG said. And this tracks, that's exactly what Dagster is. And now I want to ask something specific that relates to the time window in our RAG. So I want to see what the issues people have been running into with Dagster in the past 6 months. Now it looks like we got the "this is outside of my context window" message from ChatGPT. But as you can see here, when it looked at our GitHub issues, it was able to collate a list of like specific examples and a little bit of an explanation of the challenges users have been running into. And now within the Dagster UI, we can see the run history and the prompts and what the results were, as well as the token usage in the runs for this asset. And for our final prompt, I'm going to ask it for a specific example on how I would set up a connection with BigQuery. As we can see here, we have some nice, clean, step-by-step instructions on how to integrate BigQuery into your Dagster project, as well as relevant documentation links. With that, our RAG implementation using Dagster is now complete. I hope you enjoyed this video of building a RAG from scratch with Dagster. The link for the finished project is in the description. And if you haven't already, make sure you subscribe to our YouTube channel and follow us on LinkedIn, Twitter, Blue Sky, and join our Slack community so you don't miss any updates. Thank you.